So how do we know that this question, how do we know what law to use this to answer this question? We are going to read it and see that we are given a mass, we're given a pressure and a volume, and we are asked for a temperature. Notice that nothing is given twice. It doesn't say beginning temperature, ending temperature. It just names these things and says to tell us something about it. So that will always be the ideal gas law. So which iteration of the ideal gas law are we going to use? Well, it wants to know the temperature. So the temperature is PV over NR, where P is the pressure, B is the volume, N is the number of moles, and R is the ideal gas constant. So I'm going to go ahead and make a chart to plug things in on. I'm going to plug in my P, V, my N, and R. P on top, V on top, N on bottom, R on the bottom. So P, the pressure, is given as 202 kilopascals. I could change that to atmospheres, but I have an R value that uses kilopascals, so I won't bother with that. Volume is given as 2,500 milliliters. Be very careful. That is one of our red flags we need to look for. We cannot use milliliters. We must use liters. Remember the shortcut to go from milliliter to liter. You go bump, bloop, bloop, 3 places. So that should be 2.5 liters is our volume. So we're done with the top. On the bottom we need to put N, which is the number of moles of the gas, which is not given. Instead, we're given 25 grams of argon. So we have to, we have grams, we can find moles from grams. So we have to do a little extra mini side problem here. We use G over W to find moles. 25 grams divided by the molar mass of argon is 39.9 something. So we take 25, divide that by 39.9. This is why I should not start these without having my trusty calculator. 25 divided by, because that's 5/8, it's point. .627. 25 divided by 39.9 is 0.627. So that is going to go in, that is our number of moles. That's our moles. We're going to put that in on the bottom. Where on the bottom? Anywhere on the bottom. So I'm just going to put it right here. Anywhere will do. Always keep your labels. And finally, the only thing left to put in is R, but R is on the bottom. Now we have to be careful. The unit, we always look at our pressure unit whenever we put in R. Our pressure unit was kilopascals. So we want to use the 8.31 value, and we're going to start on the bottom. 8.31 liters times kilopascals per, but we're already on the bottom, so we flip to the top, mole Kelvin, because that is the unit for R. Now we look through and hope that there are things that cancel. We have moles on top, moles on bottom. Goodbye. Liters on bottom and top. Kilopascals on top and bottom. Boom, everything is now gone except for Kelvin. And that's what we want. We want a Kelvin. So we're going to take 202 times 2.5 divided by 0.627 divided by 8.31. And I believe we can only justify 2 significant digits right now. We have an answer of 96.92222, which is 97 Kelvin. And that's how we do that one.